Alright. Hey everyone, welcome to Math 133. This is let's see here. This is day 17, and today we're going to be looking at the Chapter 9 project. Let me turn on View as Student here. All right, so we are going to be looking at page 532 in your course pack. Page 532, and page 532 is let's see here. Here we are. The Chapter 9 project. Okay. Okay, so for the Chapter 9 project, we are gonna do a little bit more with the counts for the candy that we collected. If you've already eaten your candy, that's fine. Ours is gone, but we just need those counts. So, um, don't forget to do the 10.1 lecture notes. So we're starting chapter 10. There is one last thing to do with the chapter 9 notes, and that is the chapter 9 flowcharts lecture notes. If you click on that one, the videos are there. The links to the videos for YouTube are there. So it's not necessarily like 9.3, 9.4, 9.5. But it is still, there is still a place for you to fill that out in your lecture notes. So even though it's not necessarily like a a section, it is still something that you need to do. Okay. Okay, cool. So for the chapter 9 project, if you click on that, it will bring you here, and you can click on random confidence level file. All this is going to do is going to take you to StatCrunch. It's going to give you the ability to oh, you got to, don't forget, you got to sign in and register. This file that it's going to take you to is going to look like this, and it's just going to let us pick a random confidence interval. Um, uh, okay, so if I click on that file, it should take me, yeah, here you go. It takes me here. So, um, okay, so but the actual project is going to be on page 532, and I have that pulled up, page 532 right here. Okay. Um, okay, so uh last time when we did the candy project, we got some counts, okay? So you're gonna want to find those. It's the candy project data and graphs, the one that you saved. So these are my counts here for my M&Ms. These were for my Skittles, okay? If you're not sure where to find it, so you should have submitted that to me in Canvas, okay? But if you go to Google Drive or if you go to Google Docs, wherever you saved it, that's where you're going to find it. So I saved mine here in a folder in my drive. But if you click on Recent in Google Drive, it should be near the top. You want the Data and Graphs one. Um, the info and the pics one, that's the pictures. So yeah. Okay, great. So here I've got my M&Ms, and it looks like I didn't have very many yellow. Okay. So for page 532 for the project in the course pack, um, for the first part, which M&M color had the lowest count in your sample? So mine was yellow. Yours is going to be different, okay, depending on what was the lowest one, okay? Um, and then what you're going to put here for X is going to be the number of whatever your lowest color is. So number of yellow for me. Okay. So, I'll go to my table and write that number here. Okay. N, well, N is your sample size. Okay. And you'll remember that we were counting our entire bag as the sample size. So this is going to be the total in the bag. Okay. All right. So whatever that number is. Okay. And then p hat is your estimation for the probability. So in other words, the probability of selecting a random M&M out of all the M&Ms in the world and getting a yellow, okay, it should be around 1/6 because there's six different colors, okay? But it's going to be x divided by n. So whatever you had for x here, whatever you had for n here, okay? It's not going to be exactly 1/6, okay? Partly because we're selecting the one that had the lowest count, okay? And also because when you do a sample, your sample is random. So there's going to be sometimes you'll get some things that are more, some things that are less. Okay. Now, one thing that I'll point out is if you had uh, a very low number here, okay, um, for whatever your lowest one was, okay, that's going to be okay, as long as it's not zero. If you had zero, okay, if you had just straight up zero, um, it's going to be a little sticky with this project, okay, because there's going to be a couple spots where we are going to do some calculation, and zero does weird things, right? So uh, zero times anything is zero. Okay. So uh, for example, when we are building our confidence intervals, the confidence interval is p hat plus or minus your um, uh, plus or minus the z-score for whatever confidence level we're choosing. But that is going to be the square root of p hat times q divided by n. And so you're going to get a confidence interval, which is always going to have a width of zero, okay? Because your p hat is zero, okay? So what I would recommend in that case is select your second highest, or sorry, second lowest, okay? So if my yellow was zero, my next lowest would be orange or blue, and I would pick one of those, okay? Um, all right, hopefully that makes sense for everybody. If you had something else, if you had like a really low number here, like a one or a two or a three, it's still going to mess things up a little bit, but not as much as a zero. Okay, so if you had zero, so Melissa, you had zero brown M&Ms. I wouldn't write zero. I wouldn't write brown then for your lowest color. I would write whatever your next one is. Okay, whatever your next lowest was. Okay, that's my recommendation. Um, Uh, the other thing about that is it probably means that our sample size in that case wasn't big enough. Okay. And so we probably should have gotten a bigger bag. Okay. So another thing to point out is it's possible that you got a bag that if you had a bag with zero of something, it's possible that you got a bag that had an additional color, like one of the color, like they have like a red, white, and blue one around, the time of uh, 4th of July or whatever. So maybe you got something weird like that. Okay. Okay. Anyway, so there's that. Okay. So verify whether all the requirements for constructing a confidence interval for the proportion of this color of M&Ms are satisfied. So first of all, random. Okay. Uh, is that one a yes? That one is going to be a yes, but explain why. Okay. Because it's not just given. Okay, like when we do, one of these where it's like, oh, we took a random sample. It's like, oh, well, it says random uh, in the problem, so I'm good. Well, we didn't say the word random, so you need to explain that it is. Okay. Independent. This one's going to be a yes. Okay. And the reason why is because n is going to be less than or equal to 5% of capital N, which is our population size. And the population size what is that? So you could also write it instead as 20n. Okay, so whatever your n is, multiply 20 times that number, is that less than or equal to the population size, which in this case is all what? All what? Okay. All right. So last one, normal. Uh, this one, we take our n times our p hat times our q hat. Okay, that's going to give us a number. Okay. And is that greater than or equal to 10? Then yes. Okay, then we're good. Okay. Now for yours, it might be less than 10, in which case you might have a no. Okay. It might be that your sample size was not big enough. Okay. Certainly, your uh, if you had zero browns and you use brown here, then your x is going to be zero. Zero divided by anything is zero, so your p hat would be zero. So you would definitely be less than 10 in that case. Okay, so it's another reason why I prefer not to use zero. Now, if you have a number that's already less than 10, like 1, 2, 3, you're still going to have a no. Okay, but that's okay. We're gonna push forward. Okay. Um, okay, so next, use StatCrunch to generate a random confidence level. Okay. So basically what this is we want to randomly pick one of these numbers. Okay. So somewhere between 70 and 99. Everyone's going to get a different number, but what you're going to do is once you have this open, you'll hit data, sample, uh, select your confidence level, and just do a sample size of one. Okay. Because what that's going to do is it's going to select a single random number out of this list. Okay. So mine's 73. Okay. So I'm going to put that here, 73%. Okay. Um, we just need a random number from this list is all. Okay. Uh, so a confidence level uh is so there's a couple different terms that we're going to be using in chapter 9 that can get a little confusing what we're talking about because they're all percents, right? We have probability, and that's a percent. Okay. We have confidence level, that's a percent. Okay. And then we have margin of error, and that's a percent. Okay. So we'll talk about we'll talk about those as we run into them and try to make sure we're explaining and keeping track and not getting confused by which thing is which. Okay. All right. So regardless of whether or not the requirements were met. So earlier we said that if the normal part, random was yes, independent was yes, normal might not have been a yes. That's okay. Even if it was a no, we're going to push forward and calculate out a confidence interval. Okay. So there's a formula for it. Okay. So you'll write out the formula, okay, with all the letters, okay? Then you'll do the substitution and you're going to take your numbers for your project, which are going to be, you know, your p hat and your n and so on. Uh, and then put that in there and then put that into StatCrunch or sorry, Desmos. Desmos. You'll need StatCrunch for the substitution part for Desmos. You do a bunch of square rooting and math and dividing, and you're going to get your confidence interval. Now, a confidence interval is always two numbers. It's the low number, comma, the high number. Okay. An interval is two numbers. So what that means is when you do this confidence interval, we are figuring out, for me, I'm doing yellow. I'm figuring out that, you know, uh, here are a whole list of probabilities from this number at the low end all the way up to this number at the high end that I think that the population proportion for yellow M&Ms is going to fall somewhere in this range. Okay. It's going to fall somewhere in this range 73% of the time. And the reason why I'm saying 73 is because it's the confidence level that I've picked. Okay. Or that I got randomly. So, um, okay. And by the way, this formula and stuff, this is on page 237, uh, also on page 189. Okay. Willy Wonka claims that the proportion of candies of my chosen color, so mine is yellow, so he claims that the proportion of yellow is less than 1/6 of any bag. Okay, so he's saying that um, if I went and picked a bunch of different samples or that if I looked at all the yellows in, all the M&Ms that are ever made, that it's not 1/6, it's actually less. Okay. So he's saying that it's less than, let's see, so what is 1/6 as a decimal? Okay. So he's saying that the proportion of M&Ms that are yellow in the entire population, so in the entire world, is less than 1/6. 1/6, by the way, as a decimal one point is 16.7%. Okay, so he's saying that uh, my bag, since my bag has very few yellows, that proves that there's very few yellows in the world. Okay, is that true? We're going to circle whether that is supported or not based on whether 1/6 falls in that interval. Okay. Okay. So suppose that I had used a super big bag with thousands of M&Ms. Okay, mine had 100. If I'd had way more, it's taken a while to count them, right? Maybe yours had 1,000. I don't know. Maybe you got the big like 1 pound uh, container. Um, uh, but the proportion of your color was the same as a number one. Okay. So let's say that, I had gotten a much bigger bag, which is a bigger sample, and I still get the same proportion. Okay. The still same p hat. Okay. Confidence interval created using the numbers from this bag, is it going to be narrower, wider? Why? What's going on? Okay. You'll find that information in our course pack, page 189 at the very bottom. Okay. Uh, now we're moving on page 534. Okay. And this is for Skittles, and it's pretty much the same thing. The only difference that I'll point out is instead of looking at the one with the lowest count, look at the one with the highest. So my Skittles, I had 43 purple. Okay. So that's my highest number. So mine's going to be purple. Okay. Um, and so here we don't have to worry about zero because if your highest number is zero, then, well, you did something wrong. Okay. Um, okay. Anyway, so this, for the most part, all of this is going to be the same kind of thing. So down here, state the random confidence level. So we're going to do the same thing. You're going to get a different number this time. So over here in StatCrunch, I need to pick a random number out of this list. So I'm going to do the same thing. Data, sample, confidence levels, do a sample size of 1, hit compute. And now I got 75%. Okay. So your number is going to be different. Uh, your number is going to be different than mine. That's totally fine. Okay. All right. Page 535. We're still talking about Skittles, mostly the same information. Willy Wonka's back again, bothering you again, and claims that the proportion of candies of my chosen color was purple. So he claims that the proportion of purple in the entire population is more than 20% for any bag. Okay. So 20% because 20% is 1/5. There's five colors of Skittles. Okay. Um, does your confidence interval support that? Okay, so same kind of thing. Um, State the confidence level that I had in number three. Mine was 73%. I think that's what I had. Yeah, 73% and 75%. Okay. Yours should be different. Okay. Um, and again, this information's on page 189. Okay. All right, one more page for this project. Page 536. Okay. Um, we're back to M&Ms. Okay. And we're going to do it again. Use StatCrunch to generate a third random confidence interval, or sorry, random confidence level. So I'll jump back over here. Uh, Data, sample, and do a sample size of one. Compute. All right, this time I'm at 82%. Okay. Right. Calculate the minimum bag size required to ensure that the proportion of your M&Ms is within 2% of the true population. Okay. So the true population, so the population of all M&Ms, okay, in the entire world, uh, we expect that 1/6 of them, or 16.7% of those are yellow. Okay. So 2% would be 14, and then higher would be 18. Okay. So we want to be within 2% of that proportion. Okay. Um, there is a formula for that. That's on page 190. Also on page 239. Okay. If we switched that, not 2%, but if we switch that to 1%, okay, um, what happened there? Okay, you find that on page 190, right? Um, and then calculate the minimum bag size. Uh, this is on page 190 for the formula. Okay. All right. So, uh, and then this is also on page 190. Okay. The different relationships between these. Okay. All right. Well, so make sure you fill in your numbers, okay, that you're getting, and we'll work on this together after I stop the recording. And I will see you if you are listening to this on um, video. Make sure you do your discussion board for the week. And there we go.